This is Jonathan at GeoSolve, and today I'd like to walk you through an R script that's been really useful for making sense of this College Scorecard data frame. My purpose is not to get into the details of a lot of individual R commands, so much as it is to show you the flow of an R script and how neatly R works with sets of data. Just to give you an orientation, we're looking at this screen, which is the source script that we're going to run. This is all being done within the program RStudio. And as we go, you'll see some updates to the console. You'll see some entries to the global environment where the data frames that we're creating are appearing. So let's get started. I'm going to load the College Scorecard data frame right here. We've noticed it's populated here, 17,107 observations. Think of that as a row in Excel. 308 variables. Think of that as a column in Excel, and we can see these on our screen here. This is a data frame College Scorecard. We just loaded it in. On the very left, we have the income. This is actually the log of the graduate's income, and then a whole series of columns. Let's scroll over here towards the ACT and SAT type measures. So admissions ACT scores 25th percentile in writing. A lot of missing data for these. These NAs indicate not available. 19, that's populated. The rest of these are not. And so the next thing that we're going to get after is a tabulation of the extent to which there is missing data. And that's a one-line statement right here. We're going to populate into a data frame the not available counts. And that at this point is actually a vector, little R quirkiness, but we're going to convert that into a data frame. It'll allow us to add additional columns, and it'll actually allow us to look at it. Just open this up and you'll see, okay, now we've got a more of a row-wise orientation of our data frame. And you would read this, for this column in the original data, there are 714 instances of missing data. So 714 out of 17,107 rows are missing in our data frame. We scroll down a bit, you'll see some bigger numbers down here. 10,000 some are missing some cohort information. So 10,000 of 17,000 are missing here. A different story than for some of these other variables. We're going to quickly assign the total number of rows to this variable. It'll come in handy when we calculate the percentage right here. And if you looked in the background, you could see the data frame was automatically updated. Now we're showing not only the absolute count, but a percentage. Going past missing data, let's think about correlations, and let's have R go and calculate the correlations of each of these 308 measures against our target variable, which is the log of income. This is a pretty complicated statement here. These are dplyr chained or piped statements. It's assigning to the data frame DF core, starting from the data frame college score, selecting only the numeric columns, mutating and creating new column that is the correlation, and finally selecting the top row from there. Execute that, and we'll see a new entry appear here, DF core, which if we open, we'll see the individual correlations for each of these measures. Interestingly, intuitively, the log of income is perfectly correlated with itself. It's got a 1 or 100% correlation. Most of these other measures are not that closely correlated. We scroll across to the right. SAT scores midpoint in math, 56% of the variation in income can be explained by this particular measure. That's a very strong correlation. So this is what we're after. We're trying to find out what predicts income, and these strong correlations are a good place to start. Unfortunately, this layout is not really going to be directly usable. It's not something we can add directly here. We need to do what's called a transpose on this, which is the next statement. We're going to transpose and we're going to round from whatever these are, 7 or 8 digits of precision down to 2 with this statement. And we'll notice DF core, if we open it up again, is in a more usable format to us. Do a little cosmetic thing of adding a column name. Looks good. Okay, now we're going to merge this data frame with our larger set here. And it's going to merge by the named row IDs. This, now we'll see. We've got some pretty useful information here. Our data frame has a row for each variable, a total number of missing data expressed as a percentage, and its correlation with our target variable, the log of income. All of a sudden, we've got kind of a little bit of insight into which variables in our data set are strongly correlated and consistently populated. And indeed, the next statement in our thing is going to filter that data frame and only show those that have at least a 50% or higher positive or negative correlation. If we look at this, we'll see those entries are right here. Finally, we can write out that data frame into an Excel sheet, which looks something like this. We've got the measures winnowed down from originally 300 some down to approximately 19 or 20 of the most highly correlated variables. We can look and see this particular one, the ACT scores at midpoint in math, highly correlated. Unfortunately, we've only got a small percentage of the data populated. We can scroll down and see that school faculty salary, on the other hand, more consistently populated and strongly correlated. And just another one as an example, student share first generation parents in high school. What percentage of a student body's parents were the first generation to complete high school? Highly populated, fairly strongly negatively correlated. So in 11 R statements, we've come up with a broad understanding of the level of completeness in our data and the level of correlations with each column against our target variable. So as we've seen, R is a really powerful and terse language that's uniquely suited for doing data analysis and statistics. I hope this may inspire you to make use of this neat tool.